Here's an example of verifying an identity. It's not the most difficult one, but it's also not the most easy. Obviously the uglier side is the left-hand side, so I'm going to convert all of this into sines and cosines, especially because this piece has sine and cosines. So cotangent, I'm going to move it way over here, is cosine of t over sine of t. And then we're going to have plus this other expression, sine of t over 1 plus cosine of t. Okay, so our goal is this cosecant of t on the other side. Another way of writing it is 1 over sine. So our hint over here is, number one, it has to be one term, because the other side is only one term. And secondly, I really want a sine of t in the bottom of this, and then hopefully everything in the top will just become 1. So first of all, let's make this one huge ugly term. We're going to need a common denominator, so over here we're going to have to multiply top and bottom by 1 plus cosine of t. 1 plus cosine of t. And then on the other side, or the other piece here, is going to have to get multiplied top and bottom by what's missing, which is the sine of t. Alright, and then just simplify as much as we can. Here we're going to get cosine t plus cosine squared t. So cosine t plus cosine squared t after we distribute, plus sine squared t all over, and I'm not going to distribute the bottom because I know I want that sine of t to kind of hang out. So I'm just going to write it as the common denominator 1 plus cosine of t sine of t. Alright, and what we need to do here is recognize this piece. This is cosine squared t plus sine squared t, and that's a Pythagorean identity. This whole thing is really just equal to 1. So I can simplify this to be cosine of t plus 1 over 1 plus cosine of t sine of t. And by the distributive property, not distributive property, but the commutative property, cosine of t plus 1 is the same thing as 1 plus cosine of t. So these pieces are going to cancel. Of course, we're only going to be left with a 1. So that leaves us with 1 over sine of t. And 1 over sine of t, of course, is equal to cosecant of t, which is what we're looking for. Here's another example, and this is in terms of cosecant, secant, and cotangent. It's too much of a mixture. I'm not quite sure which one's uglier, but I'm going to go with the two pieces and try to make it one piece, like the left-hand side. So in this case, I'm going to work with the right-hand side and see if I can come up with the left-hand side. So we have secant of x. I'm just going to write it over here. Plus cosecant of x times cotangent of x. And I'm going to turn everything into sines and cosines. So this is 1 over cosine of x plus this is 1 over sine, and that's cosine over sine. So we're going to get cosine of x over sine squared of x. 1 over sine, cosine over sine, 1 times cosine is cosine, sine times sine is sine squared. Again, we're going to need a common denominator, so I'm going to multiply top and bottom over here by sine squared. And on this side, we're just going to multiply top and bottom by cosine of x. Let's see what happens. Alright, so the top, the numerator, is going to be sine squared of x plus, oh that's nice, cosine squared of x, all over the sine squared x cosine of x. Now try not to get happy about canceling things here, because you can't, because of this plus sign. We have two terms in the top and only one term in the bottom, so no canceling is going to work very well here. Remember, we're trying to get this piece. We're trying to, that's our goal. Alright, but sine squared x plus cosine squared x is equal to 1, so we're going to get 1 over sine squared x. cosine of x. Alright, so let's see what we need. Oops, I forgot my x. We need a cosecant squared of x. Well, that would be 1 over sine squared of x. And we can separate this term into two pieces and then see what happens. So we're going to get 1 over sine squared of x and 1 over cosine of x. But 1 over sine squared of x is cosecant squared of x. And 1 over cosine is secant of x. And since we arrived at what I wanted, we're done with that one. Here's one where it really doesn't matter which side you work with, you will eventually get to the other side. Most people, when they see this, they'll see the left-hand side as the uglier piece. If you're really smart about it, there is a relationship between cotangent and secant and cosecant. But then you'd have to prove another identity. So let's just go with the uglier side, change things into sines and cosines. So the left-hand side, this would be 1 over sine of x minus 1 over cosine of x all over 1 over sine of x plus 1 over cosine of x. And this is a complex fraction, so what we're going to do is we're going to multiply the top and the bottom by the common denominator, the entire top and the entire bottom. And the denominator that we're going to choose is this common factor of sine x cosine of x. And when we distribute it through the top, we're going to get the sines canceling and then 1 times cosine, so we're going to have cosine of x minus, here the cosines are going to cancel, we're going to have sine of x all over the sine of x's will cancel, we'll have cosine of x plus, here the cosines will cancel and we'll have sine of x. And no, the sines and cosines don't cancel, there's this plus and minus thing going on. Well, that's not what I want. I want things in terms of cotangent. So to create a cotangent, what I'm going to do is I'm going to force this first term, I really want a cotangent of x there. I want to force that first term to be a cotangent. So to force it, I'm going to divide everything by sine of x. That'll put a cotangent here and a cotangent there. So if I divide everything by sine of x, I'm just going to kind of put this in here as divide by sine of x, divide by sine of x. This is kind of a forced issue. You'd have to think about it where you're going to get this idea of dividing by sine of x. So cosine divided by sine, that's cotangent, so that'd be cotangent of x, minus sine divided by sine is just 1, over cosine divided by sine is again cotangent of x, and then sine divided by sine is again 1. And we've got to where we needed to go.